All right. We've taken a look at a few examples of these syllogism-type arguments and how we can analyze whether or not they're valid using Venn diagrams. The examples we've seen so far, though, followed a very straightforward template, though. We had all A or B, someone is in either set A or set B, conclusion. I wanted to take a look at a few examples where that's not the case, and it turns out both premises actually involve some kind of set relationship, and thus we need more than just a pair of circles in our diagram. So the first one I want to look at talks about voter registration, citizenship, that sort of thing. So premise 1 says all voters must be registered. Premise 2 says all people who have registered must be citizens of the United States. And the conclusion says, therefore, all voters must in fact be citizens. So we're going to need to do this in 2 stages, just like we did previously. So premise 1 says all voters must be registered. So that's an all A or B type format again. So we'll have 2 circles, one living inside another. They don't necessarily need to be that close to concentric. The picture in the handout I posted in Moodle isn't. So voter is living on the inside. On the outside, we have must be registered. Premise 1, check. Premise 2 now says all registered voters must be U.S. citizens. So at the moment, we can kind of pretend that the voter circle is not there at all. It doesn't come up in the premise. Just ignore that it's there. And we need another all A or B type arrangement. We need another circle. Since it mentions that registered people are in the A position, that's going to be on the inside. So I need another circle surrounding this guy. So big honking circle. So, and then we have citizen sitting right there. So all registered people must be citizens. The conclusion says all voters therefore must be citizens. Is there a way I could have drawn this voter circle so that it stays inside the registered circle, but somehow slips outside the citizenship circle? No, because either I'd have to move this out, in which case premise 1 breaks, or I have to stretch some part of the registered circle outside the citizen circle, which then means premise 2 breaks. So that means this is in fact a valid argument. It holds up. So that's the setup here when we're dealing with multiple, premises that involve, all A or B type statements, rather than one of them simply being this individual belongs to one group or another. Let's take a look at another. So, we will take a look now at something about baseball players, ballerinas, and athleticism. So I do this with my traditional students because I almost always have a baseball player in my class, and it's sort of fun to see how they react to the whole ballet thing. So premise 1, all baseball players are athletes. Premise 2, all ballerinas are athletes. Conclusion, therefore, no baseball players are ballerinas. You may be able to see where this is going already, but just in case. Premise 1 says we need all A or B, A being baseball players, B being athletes. So it's important to get that relationship right. I've actually messed that up before in class where I've mislabeled my diagrams and then realized I've messed up, a few minutes into a particular example. So I'm just going to use BB for baseball, and I need a big circle for athletes. All baseball players are athletes. Premise 1, now satisfied. Premise 2 says all ballerinas are athletes. So I'm going to need to draw another circle for ballerinas, and it's still in the A position in the format, so it's got to live inside this athlete circle. So I might draw it like that. Call that ballet. And premise 2, satisfied. Now, if you check the conclusion, it says no baseball players are ballerinas. All right, well, if we look at this, as I got the picture drawn, there's clear separation between baseball and ballet in here, so it looks like this, holds up. The question is, Did I have to draw the diagram that way? And you may already be ahead of me in that no, that wasn't required by the premises that came above. So I'm going to get rid of this ballet circle, and I'm going to redraw it like so. So now there's some overlap here, right? I could put a point in here that is living in both the baseball player and the ballerina circles simultaneously. So I'm still holding up both of my individual premises. Baseball circle, inside athletes. Ballet circle, inside athletes. But the conclusion breaks because now there's, no separation there. There's some overlap there. That tells me that this argument is in fact invalid. There is a way to draw the diagram so that both premises hold up, but the conclusion fails. If this feels a little bit tricky, I get that. It can be a little bit worrying. I'll be upfront with you. I'm not a terribly visual person myself, so when I deal with things like this, I always kind of have this doubt in the back of my head, did I accidentally assume something about what I drew that's not really there? Play around with some more of these, and I think you'll build up a bit of sort of mental muscle memory in terms of how this stuff needs to work out. Okay? I'm going to help you by taking a look at one more of these. I'm actually leaving one undone inside the PowerPoint slides for you to practice on your own, but I do want to take a look at one more. My apologies for the relatability here. This is talking about, traditional university students living on campus and owning a car. So just, my apologies there. But so the one I want to look at says some freshmen live on campus. No one who lives on campus can own a car. I'm going to be honest, I'm not really sure how often the university would have this sort of restriction, but I needed to make them an example, so I'm running with it. And then the conclusion says, therefore, some freshmen cannot own cars. So let's try to draw out what's going to happen for these particular hypotheses, premises rather. Sorry for the slip there. Sometimes you'll hear them called hypotheses, but the premises, let's draw out a Venn diagram that shows how they hold up, how they interrelate. So the first one says some freshmen live on campus. So in this instance, I need number 2. I'm finally not an all A kind of situation. We need the 2 overlapping circles, kind of like we were used to seeing in our Venn diagrams before. So I've got 2 circles like that. Got freshmen and living on campus. I'll just call that OC. So own car could also be abbreviated OC. I'm just going to write car when it comes time to draw that thing in. So premise 1, check. Some freshmen living on campus. There is an intersection or an overlap. Second premise, no one on campus can own a car. So that is a no A or B type thing. And so I'm going to have to draw a circle that says, sorry, just drew a blank, that says no one on campus can own a car. Good grief, I apologize. So I need a car circle that does not overlap the on-campus circle. There's a few different ways I could draw this. So what I'm going to try in this instance, I'm going to put it over here. So that works. So I'll call that guy car. I could draw it a whole bunch of other ways. I could draw a completely separate thing over here. I could draw it like that. The key thing is car and on campus don't overlap at all. So premise 1, check. Premise 2, also check. Now we take a look at the conclusion. This one is a little bit trickier because it's not directly some A or B. It says some A are not B. So the catch is, in this particular example, is there a way that I could completely overlap the freshman circle with the car circle? No, unfortunately I can't, because if I move it that way, I can't pass over the on-campus circle, so I'm stuck. I could try drawing it ever closer, but I can't let these 2 circles overlap. So there's always going to be a piece of the freshman circle, this part right here, that the car circle cannot contain. So as it turns out, in this instance, this argument is in fact valid. So technically, again, if it had said some freshmen can own cars, yeah, that like I said, it trips things up a bit. So you could draw it that way, and it still works out just fine. This exact Venn diagram still actually satisfies that, and there's plenty of ways you could draw the diagram so that happens. You don't necessarily have to, but can is kind of a flexible word there. So that's what I was wanting to take a look at as far as argument analysis and Venn diagrams. As I said, there is one more example in the PowerPoint slides that I'd like for you to try on your own. There's also a handful of homework exercises where you get to play around with these things and see whether or not particular arguments hold up or not. Again, if you're not 100% comfortable with this, I get that. I'm totally on board because, yeah, it took me a while when I first started teaching this course to get my head around making sure I was drawing these diagrams the way I wanted them. If you're uncomfortable with that, we're going to have another way to look at these arguments eventually, but we need to build up some tools before we can talk about that. And that's the content of the next video.